Evet, sorusu olan var mı buraya kadar? Tabii notta muhtemelen tutamıyorsunuzdur. O yüzden soru sormak da zor oluyor olabilir. Okay. What we were doing, let me just remind you. Given equation like this, suppose it is not exact, okay? We wonder the following. Can we find a function mu xy so that after multiplying the equation with that function, the new equation becomes exact? Well, if this is exact, then of course we know that x derivative of the m term, the new m term, which is m times mu, should be the x derivative of n times mu. And if I open this up, I get a PDE. Well, this is probably difficult than the original equation, right? The variable here is mu xy, and it has derivatives with respect to x and y in the equation, so this is probably a more difficult equation. Well, to make life easy, we make some sacrifice. We do what? We say we don't want to get all the integrating factors. We just want integrating factors of special type, okay? If there are some special type of integrating factors, we will be happy with them. The rest, we just, don't want to deal with. What is that? So we make the following assumption, okay? Yani bu aşamada bütün integrating factor'ları bulmaktan artık vazgeçiyorsunuz. Bu bir yerde nedir? Hani şey yapıyorsunuz. Tamam, ben hani o kadar iddialı değilim. Bütün integrating factor'ları bulmak gibi bir niyetim yok. Belki bir takım özel integrating factor'lar vardır. Onları bulsam yeterli. Ama eğer onlarda yoksa artık yapacak bir şey yok. Çünkü PD ile uğraşmak istemiyoruz. Assumption'ımız da şu. Assume that mu xy is a function of x only, or a function of y only. Okay. If this is the case, then some of the partial derivatives will disappear and we will get something relatively easy. So what is the what are the cases now? Case one is this. So we look for a function of x only. So we let our function mu as a function of x only. Function of x only. Okay. In this case, of course, we get what? Hence, mu sub y, first of all, is 0, and this mu sub x, well, that is nothing but the, derivative mu over dx. Okay, now let's come back here. Well, mu sub y is 0, so this is gone. So it became an ordinary differential equation. Let's see. Okay. What is the equation then? M sub y mu equals n sub x mu plus n times mu sub x. Mu sub x is just d mu over dx. Okay, so that's the equation. That's the equation. So this gives us what? This gives us the following. Not dy, d mu dx. Okay, so we get the following. M sub y minus n sub x times mu is equal to n times d mu dx, and from this we get m sub y minus n sub x dx okay, ya da şöyle yazayım, divided by n is equal to what? D mu over dx divided by mu. Alright, now let's see what we have. Here I have derivative of mu divided by mu. Mu is a function of x only, therefore its derivative is a function of x only. Mu is a function of x only, therefore this ratio is a function of x only. Well, about this gadget, well, we don't know, of course. M and n are both functions of x and y, and there is no reason why this should be a function of x only. But if it is the case, then I can solve this equation. This becomes a separable equation, and I can solve this. Okay, so the conclusion is this. Note that the right-hand side, which is just mu prime over mu, is a function of x only. Hence, if the left-hand side, which is just m sub y minus n sub x divided by n, is a function of x only, then we can solve this equation for mu, because it's just a separable equation and obtain an integrating factor. Okay, for the original ordinary differential equation. Okay, what about the other case? So this is the case 1. Case 2 is the following. Maybe there is a function integrating factor which is a function of y only. Function of y only. What happens in this case? Then mu sub x this time is 0, and mu sub y is nothing but d mu over dy, right? Because it's a function of a single variable. And what happens to the equation then? Okay, so our equation was yeah, here. So this time this is 0. So we get what? M sub y minus n sub x. Or maybe I take it to this side. Well, let me just write down this expression again down here. So hence the equation for mu becomes what? Yazayım ben size denklemi tekrar. Denklem şuydu. Mu sub y m plus mu times m sub y mu sub x n plus mu times n sub x. And this was 0. So we get what? We get okay, mu sub y times m is equal to n sub x minus m sub y times mu. And from this we get mu sub y is just d mu dy divided by mu is equal to n sub x minus m sub y divided by m. This is almost the same expression as this one, right? M and n are replaced. N sub x minus m sub y divided by m. Okay. All right. But don't try to memorize these expressions because you always misremember them. Uh, just keep how this is derived, and during the exam, just write down and obtain this expression. Don't try to memorize it because you most probably remember something wrong. Okay, this was mu. Sorry. Now what we have here? Well, mu by assumption is a function of y only. Therefore, this derivative term is a function of y only. Mu is a function of y only. Therefore, the left-hand side is a function of y only. Therefore, I can solve this for mu only if the right-hand side is a function of y only. So this time, the left-hand side is a function of y only. Thus, if n sub x minus m sub y divided by m, okay, is a function of y only, then we can obtain an integrating factor mu sub y for the equation mu of y for the original equation. Okay. Now let's see these on some examples. Sorusu olan var mı arkadaşlar buraya kadar? Okay. Some examples. Bir şunu yapayım. Okay. Solve the equation. Okay. 3 xy plus x squared pardon şöyle diyeyim. Soruyu biraz değiştireceğim de y squared plus xy plus 3xy plus x squared y prime equals 0. Okay. All right. So, solution. Well, this equation is terrible looking. It is not linear. It is not well, actually, it is homogeneous. Maybe it's not that terrible, but let's try to solve it as if it's an exact equation. So let m to be y squared plus xy and n to be 3xy plus x squared. Then what is m sub y? This is just 2y plus x, and n sub x is just 3y plus 0. So no, 3y plus 2x. And these functions are clearly not the same, uh, since m sub y is not equal to n sub x as functions. The equation is not exact. Okay. So what we will do, we will look for integrating factors. So look for an integrating factor. Uh, okay. So first, let's look for an integrating factor as a function of x only. X only. Then we get what? Okay. Now what we want is this, right? M times mu plus n times nu dy dx has to be exact. Has to be exact. Well, this means what? Y derivative of this should be x derivative of this. Well, y derivative of this is just m sub y mu plus m times mu sub y equals n sub x times mu plus n times mu sub x. And I want mu is a function of x only. Therefore, this thing is 0 and this is just mu prime, or d mu over dx. So we get what? We get the following: d mu over dx over mu is equal to m sub y minus n sub x divided by n. Alright, now what are these gadgets? What was m sub y? M sub y, işte tahtamız olmadığı için yukarı çıkmak zor oluyor. M sub y şuydu: 2y artı x. 2y artı x eksi n sub x 17. O da 3y artı 2x. 3y artı 2x bölü n. N neydi? N de 3xy artı x kare. What is the function of x only? Well, what is this? This is just eksi x eksi y. Burada da x parantezine belki alabiliriz ama sonuçta şu var. Bu da pek x'in fonksiyonu gibi durmuyor. Right? Not a function of x only. This means what? Even if this equation has an integrating factor, it is not a function of x only. So we have to try our chance in the other case. So this time we look for an integrating factor which is a function of y only. Function of y only. what was the equation for this? It was the following: d mu over dy divided by mu. Uh, this was n sub x minus m sub y divided by m. So the numerator is the same, only the sign is different. So this is x plus y. And what is m? M was y squared plus xy. Y squared plus xy. Well, this time we are lucky because if I take the denominator uh, into the y parentheses, this is what I obtain. X plus y's are gone, and this is just 1 over y, which is a function of y only. Hence, so a function of y. So we can find the integrating factor as a function of y. How? Well, we just solve this equation. D mu over mu. I have this dy here in the new denominator. I take it to the other side. I get dy over y. So I need to solve this equation. Well, there is an obvious solution. Hence, right, mu y equals the solution, right? If I put mu equals y, then both sides are the same, is a solution. So y is an integrating factor for this equation. What else? Now we will just go back to our original equation, multiply it by y, and then solve it. All right, let's do that. This was our equation. So I will multiply this by y. If I multiply this by y, I will get y cubed plus xy squared. Y cubed plus xy squared plus nerede kaldı? Evet, yok. Biraz daha. Y plus xy squared. Bunu da y ile çarpıyorum. 3xy kare artı y çarpı x kare. 3xy kare artı neydi? X kareydi. Y ile çarptım. Y x kare. Y x kare dy dx equals 0. Now this has to be exact. This equation must be exact. But let's check whether it is really the case, okay? So this is the new m term. Y derivative of this should be x derivative of this gadget. Let's see if it is the case. Y derivative of this is just 3y squared plus 2xy. Is this equal to x derivative of this 3y squared plus 2xy? Yes, it is. What about the other conditions of the theorem that we have simply connected region and so on? You see, both m and n are polynomial functions and they are continuously differentiable everywhere. Therefore, we may take our rectangle R to be the whole plane, okay? And it is, of course, simply connected. And these are the same, therefore this is an exact differential equation. How can we solve this? Well, let mu uh, xy be so that x derivative is m, which is y cubed plus xy squared, and y derivative is n, which is just 3xy squared plus yx squared. I don't need parentheses here. Well, we have to find now, find this function. Well, how can we do this? Well, mu sub x is equal to y cubed plus xy squared. Therefore, mu xy is just antiderivative of this with respect to x. What is that? This is x times y cubed plus x squared y squared over 2 plus a constant. But since we are taking derivative and integral with respect to x, I should regard y as a constant. Therefore, the constant term in general must be a function of y. And what is this h sub y, h of y? Well, I will use the second equation to determine h. What was it? So 3xy squared plus y times x squared should be equal to psi of y. And what is that? Derivative of this gadget with respect to y. Well, that is just 3xy squared plus 2, okay, not 2, 2's are gone, x squared y plus h prime y. Alright, if you compare these two, well, you see that all these terms are cancelled. Therefore, h prime y is just 0. And h is a single variable function. Therefore, h of y should be a constant. So, our function xy is equal to this. X y cubed plus x squared y squared over 2 plus a constant. Right? Hy is a constant. And the solution of the equation is just, what's the solution? X y cubed plus x squared y squared over 2 plus c is equal to another constant, but we don't write it this way. We just, we can write it this way, like this. So, and c is any real number. So that's the solution. Okay. All right. Do you have any questions so far? Okay, if you don't have a question, let me do another problem from the book. Let me just open. Okay. Okay. All right. Let's see. Let's solve problem 27 at page 102. So the problem is solve the equation 1 plus x over y minus cosine y prime is equal to 0. So that's the equation. Sanki y çıkacakmış gibi duruyor şey. Bunu böyle başka soru yapayım. Burada da çünkü şey gibi gözüküyor. Integrating factor aynı olacak gibi. Okey. 26 yapayım. Okey. Y prime is equal to e to the power 3x. O lineer denklem ya. Yok, başka bir tane yapayım. 28'e bakalım. Okey. Y plus 2xy minus y times e to the power minus 2y y prime equals 0. So 2xy minus y times e to the power minus 2y times y prime is 0. Alright, so let's see what we get. What is mxy? Well, this is y. And what is nxy? This is just 2xy minus y times e to the power minus 2y. Okay, what is m sub y? It is 1. What is n sub x? It is 2y. And they are not the same. And thus, the equation is not exact. Uh, let's look for integrating factor. Look for integrating factor. K is 1. Mu is a function of x only. What was the equation for that? Bakayım burada varsa yazayım, tekrar onu drive etmeyeyim. Şurada, evet. Şuna bakmamız gerekiyor. Ama normalde hani ezberlemeyin bunları. Çünkü dediğim gibi hep yanlış hatırlarsınız. Nasıl çıktığını bilirseniz hani bulmanız birkaç dakikanızı alıyor. Çok uzun değil. Okay, so let's see what we get. Okay, I write it this way, of course. Mu'yu da bu tarafa atıyorum. M sub y. M sub y 1'di. Eksi n sub x 2y divided by n. N neydi? 2x ya da y parantez, bir dakika. Burada mı şey çıkıyormuş? Neyse, tamam. 2xy minus y times e to the power 2y. Evet. Bu da pek x'in fonksiyonu gibi gözükmüyor. Not a function of x only. So there is no such integrating factor. Now we'll look at the case 2. This time we'll look for an integrating factor, this type. And the equation for that will be what? Du mu over dy divided by mu is what? N sub x minus m sub y divided by m. N sub x neydi o? N sub x minus m sub y. Burası şey olacak. 2'ye eksi 1 olacak. 2'ye eksi 1. M neydi? M'de 1'di. Yok. M y'ydi. Tamam. Onu da yazalım. Y. Dolayısıyla ne elde ettik? 2 minus 1 over y. Okay. So it's a function of y only. Therefore, such integrating factor exists. I have this equation for the integrating factor 2 minus 1 over y dy. Right? I take dy to the other side. This is what I obtain. And from this we get what? ln mu is equal to integral of this, and that is just 2y minus ln y plus a constant. But as usual, since we are just looking for one integrating factor, I don't want the whole family of integrating factors. So I can just choose this constant to be 0, okay, to make life easy. And this is what I get. And from this we get mu is equal to, I have to exponentiate this. What is the exponential of this? It is just e to the power 2y times e to the power minus ln y. Well, this is just 1 over y, so it is just e to the power 2y divided by y. So this is my integrating factor. Now I multiply my equation with this integrating factor. Let's see what we get. Şimdi denklemimiz neredeydi? Neyle çarpıyoruz? Y çarpı ya da kitaptan yazayım, soruyu zaten yapmıştık. Şuradaydı, 28. soru. Buradan kopya edeceğim ve kitaptan edeyim. Okay, my equation was y plus 2xy minus y times e to the power minus 2y, y prime equals 0. I multiply this by the integrating factor e to the power 2y divided by y. So let's see what we get. This becomes just e to the power 2y plus here I get 2x times e to the power 2y minus y'ler gitti. Bunlar da gitti. 1. Y prime equals 0. So this is my new equation. My new equation. So this is my new m and this is my new n. Let's see if it is exact. Check if it is exact. Okay, what is m sub y? Well, it is just 2 times e to the power 2y. What is n sub x? X'e göre türevini alıyorum. O da 2 tane e üzeri 2'ye. Well, they are the same. So it is exact. Yes, it is exact. And then we can solve this. So we want a function psi xy so that its x derivative is m and y derivative is n. So mu sub x is equal to m. M neydi? E üzeri 2'ye. So what is mu psi then? Well, I have to integrate with respect to x. So this is just x times e to the power 2y plus a constant, which is a function of y in this case. And to determine h of y, I have to use the other equation. So n equals psi of y. N is what? N neydi? 2x e üzeri 2'ye eksi 1. 2x 2x e üzeri 2'ye eksi 1. Okay, this has to be derivative of psi with respect to y. What is that derivative? Well, it is just 2x e to the power 2y plus h prime y. Okay. I compare these two and we see what? From this we see that h prime y has to be minus 1. Therefore, h of y should be minus y plus a constant. Hence, psi y is the following function. It is just x times e to the power 2y plus y, h of y, which is y plus c. Okay, so that's the psi function. What is the solution? Solution is this, right? This thing is not solution, right? I mean, if you write this, this is not the solution. This is just a function. Solution has to be a function of x. And that solution is the following. That solution is this implicit equation. Here, this is an equation in x and y, but implicitly we can solve y in terms of x, and that's the solution of the differential equation. And what is c? C is any real number which can be determined once we are given an initial condition. For example, if we were given an initial condition like say like 0 equals 5, then we would get what? When you plug these values, you get 0 times e to the power 10 plus 5 plus c equals 0, and this would give us c equals minus 5. Therefore, uh, uh, x times e to the power 2y plus y minus 5 equals 0 would be the solution of the initial value problem. Okay, all right. Next section is existence uniqueness theorems, but we have already actually studied this, so I will not do 2.8 since we already discussed it in 2.4. So I think I may stop at this point.